talking about properties of special parallelograms. We talked about parallelograms yesterday, and we have to remember the 5 properties of regular parallelograms. The first one was that opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary, and that diagonals bisect each other. Now we have to keep these in mind because now we're going to be talking about some special parallelograms. Our first one is a rectangle. Now a rectangle is a type of parallelogram, so it does have all the properties of a parallelogram. Has all the properties of parallelogram, but it has 2 special properties that just are for rectangles, and that all angles are congruent, meaning that they are 90 degrees. So we have 90 degrees on each of these. And the next one, the next piece that's special to this is that diagonals are congruent to each other. So their diagonals are congruent to each other. So this is our properties of our rectangles. What we have next is we have a rhombus. Okay, a rhombus is a type of parallelogram, so it does have the properties of a parallelogram. So all those properties of a parallelogram apply to a rhombus, but there's a couple of extra special properties that we can use just for a rhombus. And what that is diagonals are perpendicular, meaning that if we draw diagonals, that all the angles on the inside are going to be 90 degrees. What also is special about a rhombus is that all sides are congruent to each other. And another thing about the diagonals is that diagonals bisect opposite angles. That means that right here, these 2 angles are equal to each other. So if this is 15 degrees, then this will be 15 degrees. So those are special properties just for rhombuses. Now a square is very special because it is a parallelogram, so it still has the properties of a parallelogram, but it also has the properties of a rectangle, and it also has all the properties of a square. Of a rhombus. So a square is really special because it has all the properties, including the parallelogram, the rectangle, and the rhombus. So we can use any one of those properties to solve for missing sides and angles. So we're going to use these properties to solve for missing things. So it says the following parallelogram is a rhombus, solve for x and y. Since we know this is a rhombus, we can use the properties of a rhombus and a parallelogram to solve. So let's solve for y first. Y is at the sides, and we know that the rhombus has congruent sides. So we can set 2y plus 3 equal to 5y minus 6. And then we can solve. Add the 6. Y will equal 3. Now our next one, x is at an angle, and we have another angle 85. These angles are consecutive, and this is a parallelogram property. We know that consecutive angles are supplementary, so they equal 180. So we can do x plus 180, x plus 85 is equal to 180. We can subtract. And we get 95 for x. So for a rhombus, we can use rhombus properties and parallelogram properties. Let's look at another example. This one, we have another rhombus, so we can be looking at the rhombus properties and the parallelogram properties. Number 1 says find angle, the measure of angle DAC. Measure of angle DAC. So we're looking for this piece. Well, we know that diagonals bisect opposite angles, so that angle is congruent to 32 degrees. So the measure of angle DAC is 32 degrees. Let's look at where x is. X is right here and right here. Well, if we notice, those angles, just like that, form this Z. And remember that parallelograms have parallel lines. Parallel lines can give us alternate interior angles, and alternate interior angles are congruent. So what we can do is we can say that 5x minus 8 is equal to 3x plus 24. So using one of our properties from a parallelogram. Subtract. 8. 32, so x will equal 16. Okay, now we have to look for the y. The y is at this angle in the middle, right here. Well, we know that the diagonals of a rhombus are perpendicular, and perpendicular lines give us right angles, or 90 degrees. So we can say that 3y is equal to 90, divide by 3, and y is equal to 30. So we can use rhombus properties and parallelogram properties. All right, the next one. We have to classify the special quadrilateral. Well, since it has 90-degree angles, this is a rectangle, and it's elongated. It is a rectangle. So we're going to solve for x, y, and z. Well, let's solve for x first. X is at the corner of a rectangle, and the corner of a rectangle is 90 degrees. So to solve for x, we can say 3x minus 7 plus 2x plus 22 is equal to 90. If we add those two pieces up, it will equal 90 degrees. Combine like terms, 5x plus 15 is equal to 90. Subtract our 15. 75, divide by 5, it's 15. All right, let's solve for y. Y is over here, and it says y is at AD and BC. Well, AD and BC are diagonals of the rectangle, and we know that diagonals of a rectangle are equal. So we can say 5 times y minus 3 is equal to 3y plus 1. Those are equal to each other. Now we can solve, so we distribute. 5y minus 15 is equal to 3y plus 1. Subtract the 3y. 2y minus 15 is equal to 1. Add the 15, 2y equals 16, y is equal to 8. Now let's find our z. Our z are at opposite sides, and opposite sides of a rectangle are equal. So we can say 25z minus 10 is equal to 5z plus 50. Let's subtract that 5z. So we get 20z minus 10 is equal to 50. Add the 10. 20z equals 60. So z is equal to 3. We used our properties of rectangles and parallelograms to solve. Our last one, we're looking at a square. A square has all the properties, so we can use all properties of parallelograms, rectangles, and rhombuses. Let's solve for x. X is at the side, and we know all sides of a square are equal, so we can say 2x minus 6 is equal to 4. Let's add those. Divide. X is equal to 5. Let's look at our y. Our y is at this angle in the middle, and we know that all the angles in the middle are 90 degrees because those diagonals are perpendicular, so we can say that 5y is equal to 90. Divide by 5. And we get 18. Our last one is z, and z is at this piece right here. Well, we know that that angle is 90 degrees and that that diagonal bisects that 90 degrees. So this piece has to be 45 degrees. So this is going to be 3z plus 3 is equal to 45. 3z is equal to 42. Divide by 3. And we get 14.